Right now, we're living through the start of a whole new industrial revolution. Seriously. But this one isn't about steam or steel. It's powered by artificial intelligence. The very foundation of computing is shifting under our feet. And today, we're going to break down exactly why it's happening, what the solution looks like, and what it's all being built for.
Okay, let's just let that sink in for a second. The scale of this change is being talked about in truly historic terms. This isn't just about a simple upgrade, like the next smartphone. No, this is being framed as a fundamental leap forward, kind of like the invention of the microchip or the internet itself. And the key thing to get is that this isn't some far-off future. We're being told the next great era is already here.
So, what's actually driving this massive revolution? Well, like a lot of big stories, it all starts with a problem, a really big one. For more than half a century, the engine of our digital world has been chugging along, powered by this one super reliable principle. But that engine, well, it's finally run out of road.
And that principle? That was Moore's Law. For 60 years, this was the heartbeat of Silicon Valley. It was the simple observation that computing power would basically double every couple of years. It meant our computers got faster, more powerful, and cheaper, like clockwork. This law powered everything from the first PCs to the smartphone that's probably in your pocket right now. It was the predictable, beautiful rhythm of progress.
Until now. As NVIDIA's CEO put it, we've hit a wall. And that wall is the actual laws of physics. We literally can't shrink the tiny transistors on a chip any further and expect to get the same performance gains we used to. That reliable rhythm, it's just stopped.
And this is where the crisis really hits. At the exact same moment that traditional computing performance is hitting a plateau, the demand from artificial intelligence isn't just growing, it's exploding exponentially. So what you're looking at is this massive, ever-widening canyon between what we need AI to do and what the old way of computing can actually deliver.
And that brings us to the central, multi-trillion-dollar question facing the entire tech world. When you have this insane, exponential demand for AI, from making models smarter and from billions of people wanting to use them, how in the world do you keep up? The old playbook is totally useless here. You need a new one.
And that new playbook has a name: accelerated computing. It's a completely different way of thinking that's designed to solve this exact problem. Instead of trying to make a single processor do everything just a little bit faster, this approach reinvents the entire model from the ground up.
Here's the fundamental shift. Think of it this way. The old way was like having one super smart worker, the CPU, trying to tackle 1,000 different tasks one after another. The new way teams that smart worker up with a GPU, which is more like an army of thousands of specialized workers all doing their one thing at the exact same time. GPUs were first designed for video games, for rendering complex graphics, which meant doing millions of simple calculations all at once. And it turns out that parallel processing superpower is absolutely perfect for the massive number crunching that AI needs.
Right, and this is so crucial to understand. You can't solve an exponential problem with just one good idea. You can't just slap a new chip in and call it a day. No way. It takes what they call extreme co-design, which basically means you have to rethink and reinvent the entire system all at once.
So this strategy means you're co-designing every single layer of the puzzle at the same time. You're not just building a better chip. You're building a new chip specifically for a new kind of computer system, which is built to run new kinds of software, all of which is designed to live inside a totally new kind of data center. Every single piece is optimized to work perfectly with all the others.
And the results of this strategy? They're just staggering. I mean, we're not talking about those small incremental gains we got used to. 25% here, 50% there. By reinventing the whole stack, NVIDIA is claiming a 10-fold performance leap in a single generation. That is how you start to close an exponential gap.
So what do you do with that much power? You don't just run the old data centers a little bit faster. You build something completely new, something they're calling an AI factory. Now really think about that term for a second, a factory. Unlike the data centers of the past that did a million different things, hosted websites, stored your photos, ran apps, an AI factory has one job. It manufactures intelligence. Its finished product is what the AI world calls tokens, the basic building blocks of language, of code, of images, even of scientific discoveries.
And just like any other factory, say, one that makes cars, its goals are pretty simple, right? First, you want to make the best, most valuable product you can. Second, you want to produce that product at an incredible rate. And third, you want to do it all for the lowest possible cost. This industrial mindset is at the very core of this new era.
And that's how we come full circle. These AI factories, churning out intelligence as a new kind of commodity, are being positioned as the literal engines that will power this new industrial revolution, transforming every single industry they touch.
So, if producing digital intelligence is what's happening right now, what's on the horizon? Well, the next great frontier is taking all that intelligence out of the data center and putting it to work in the physical world.
Now, to make that happen, you actually need a pipeline of 3 different super powerful computers. First, you need a massive AI supercomputer, the trainer, to teach the AI model using tons of data. Then, you need a simulator, basically a super realistic virtual world where the AI can practice safely for millions of hours without breaking anything. And finally, you need a powerful but tiny computer that goes inside the actual robot to run the AI in the real world.
And look, this isn't some far-off sci-fi movie pitch. This stuff is already being deployed. We're seeing it in robotic factories, building cars and electronics. We're seeing it in the incredible race to build humanoid robots that can work alongside us. And of course, we're seeing it in self-driving cars, which are essentially our first mass-market AI chauffeurs, learning to navigate the chaos of the real world.
The ambition here is it's off the charts. It's being framed in these really monumental terms, with some comparing the sheer scale of the challenge and its potential impact to the Apollo moon missions. It's a call to action for a whole new generation of engineers and innovators.
Which leaves us right here, with this final thought. We are standing at the very beginning of this new era. The engines of the AI revolution are being built and fired up as we speak. They're designed to manufacture intelligence at a scale we've never seen before. The only real question that's left is, what are we going to create with them?